In this video, I'm going to show you how to find all of the different angles that you can get when you're solving for the angle in a trig function, knowing that your calculator only gives you one of those angles. So now I will point out ahead of time that there are a couple things you should know before we get too far into this. One is that you can actually do the same thing with cast and related acute angles, or the bow tie diagrams, although honestly I find it a little bit more difficult to see. I find this one much more easy to visualize and easy to kind of do in your head. I will also do them in degrees instead of radians, only because the numbers are nicer if it doesn't work out to be like a nice fraction like pi over 4 radians or something like that. If you're working with decimal numbers, radians become a little bit difficult because then you're not really working with 2 pi, you're working with, 6.28 something. Um, so we're just going to start with degrees, but I will show you how it works in radians as well. So let's start with the sine function, which I have here. And you'll notice that I have a complete sine function from 0 to 360 degrees. Um, Basically, that represents the four quadrants. The first quadrant being 0 to 90 degrees, that's the little part going up. Second quadrant going down. Third quadrant going down again. Fourth quadrant going back up to 360. All four of those pieces are identical in shape. It's just, for instance, these two are mirror images of each other. And then these two are the same as the first two, but flipped vertically. So let's start by just doing, for instance, y equals sine x equals 0.6. So this is the answer right here that your calculator gives you, which is about 37 degrees, at least when we round off. So that would be a 37-degree answer, and we want to find out the other answer, which we can visually see is right over here. The question is, can we find that without the graph, or at least without using the graphing software to give it to us? And the answer is yes. So if this is 37 degrees from 0, symmetry tells us that the other one must be 37 degrees below 180 because we're going the same amount up the hill this way as we're going to go up the hill this way. So really the equation for that one is going to be 180 minus 37, which should be 143. And if we click on it, sure enough, it is 143. Now the only other trick to this one is, what if the ratio that you're solving for is negative? So instead of solving for 0.6, let's solve for negative 0.4. So now the likely angle your calculator is going to give you, and I say this because not all calculators are identical, but likely it's going to be this one, which is approximately negative 24 degrees. So if we look at that, that's 24 degrees below the zero. Not that it's a temperature, but 24 degrees below the 0 point. And the two places where it should look like that again are 24 degrees below 360, and 360 minus 24 would be 336, which it is. And the other one is going to be 24 degrees above 180. So 180 plus 24 should be 204. And sure enough, it is. So you could break that down into a whole bunch of different equations, and you can do it in different scenarios, whether it's positive or negative, but visualizing the graph is actually much easier. So I'm going to actually go over here to the graphing calculator, the exact same one. The only difference between this graph and the last one you'll notice is that these are in radians instead of degrees. So we have the 0 radians, um, pi over 2, pi, and 2 pi. Oh, and 3 pi over 2. There we are. And if we wanted to solve the same thing there, we could. The only thing is, like I said, this isn't a nice number as far as it's not a fractional number of radians. So we'd have to pull out the calculator and say if this one is 0.644 above 0, the other one should be 0.644 below pi. So you'd have to type in 3.14159 or pi and subtract 0.644, and that'll give you the 2.498. And then the exact same logic if we went with the negative version. So whatever number you get here, 0.412, it's negative, but all we care about is its magnitude, 0.412 to the left. Then this one should be pi plus 0.412, and this one should be 2 pi minus 0.412. Okay, I'm going to go back to degrees just because, like I said, the math is a little bit nicer. It's easier to see, but it does work with radians. You just have to convert everything to decimals. Okay, so that was for sine. Now, if you understand kind of the idea of the symmetry there, the others are actually no harder. They're different, but no harder. This is what the cos curve looks like. And again, if we look at it over one full normal cycle, it starts off at 1, goes to 0, -1, and 0, +1. Those are the 4 quadrants. I'm going to turn that off for a second. And same thing, if we want to solve cos equals positive 0.4, our calculator will give us this number right here, 66 degrees. And if we think about what it looks like for one complete cycle, it should be back at the same place at 360 minus that amount because it's symmetric above 0 and below 360. Complete symmetry there for one cycle. So that one should be 360 minus 66, which would be 294, I believe. And that's what it works out to be when you round off. And then same logic if we do something like negative 0.8. This one here, the calculator should give us 143 degrees. Again, your calculator may be different. It may give you another one, but you can use this same symmetry idea to find out any of these regardless of what your calculator tells you. So the 143 is one of the angles, and the other one should be 360 minus 143 because it's the same distance from the other side of the graph. So 360 minus 143 is what, 217? And yep, looks correct. Okay, if you got that one, tan is the easiest of them all. So for tan, let's go for, oh, this one, sine and cos are limited between 1 and -1. Tan isn't. So let's do cos x equals 1.4, just for interest's sake. And one of the angles that it gives us, which is likely going to be that one, is 54 degrees. So it turns out that if you look at the shape of the tan graph, it just repeats itself every 180 degrees. So here it's at 0 and it goes up. 180 degrees later, it starts at 0 and goes up. 360, it starts at 0 and goes up. So once we have the first one, the next one should just be 180 plus that. So 180 plus 54 is 234. And then the other one is beyond 360, so we're not usually worried about it. But if we wanted to keep finding more of them, we would keep adding 180 degrees. So that would give us 414, I think. And yep, that's that one. So the nice thing is once you've got tan, you just add add 180 each time you want to find each of the others. Now normally that's only doing one, but again, if we had tan x equal to, let's say, negative 0.8, the calculator is likely going to give you this answer right here, negative 39 degrees. But that's okay, because if we want to find the next one, it's just going to be 180 minus 39 degrees. So that would be 141. And the next one would be 180 over that, which would be 320, oh, I'm losing track of stuff here, 321. There we go. So once you've got one of the numbers in your calculator, just add 180 to find any additional one. And that's pretty much it. Again, if you can visualize these in your head, and I don't think that's unreasonable. I think most people can take a look and think that sine starts at 0, goes up, down, down, up. That's one complete cycle. You should be able to visualize the symmetry between 0 and 180, and the symmetry again between 180 and 360. With cos, it's even easier. Symmetry between 0 and 360. It's just a mirror image side to side. And tan, easiest of all, just add 180 from one angle to get to any other angle that's equivalent. All right, that's it. Good luck.